All right, so let's talk a little bit more about some of the things that we believe are happening. Now, I was praying I was going to get a backup data for one specific report, which I don't feel comfortable sharing just yet because I got to get backup data on it. But it appears that during the process, the biology is helping to precipitate out the nutrient into a stable organic form. And by stable organic, I mean it's non-mobile. It's not going to wash throughout the soil system. It's there, it's stable. It's not going to oxidize. It's not going to volatile or it's not going to turn into a gas or anything else. The only thing that can unleash it is the actual bacteria that would normally be associated with that type of organic nitrogen. And that's where he was talking about that this actually fixes nitrogen. So maybe you can speak a little bit on that for a minute, Mo?
Yeah. So the, like I said, the bacteria causes non-legume plants to act like legumes for a period of time. So as your bean plants have like nodules on their root systems that allow them to fix nitrogen, and through some other biology that accomplishes that, this bacteria, when it gets absorbed into the root systems, accomplishes the same thing. And when you have your nematodes, your protozoa, the organisms that take in the bacteria, also help this process happen. But that's the cornerstone right there of how this whole process works, is what is that function of the bacteria. Now, the nutrients themselves are broken down in your more complex compounds are broken down into their elemental states. So you have these ions floating around throughout the liquid as well. And that material is then more readily absorbable and usable by the plants. So as one of the examples I use frequently is like calcium carbonate is separated. You have your calcium ion then floating around in the liquid, which is more readily available than if it's in the calcium carbonate form. Another example I give people as I tell them about this, like in wastewater treatment, you have aluminum sulfate is a common compound that's used in wastewater treatment, but that material has to be broken down. So one of the things that we see in our process is that compounds like that, like in the wastewater treatment, if you use just the aluminum ion as opposed to the aluminum sulfate, use 1/3 of the amount of compound you would normally have to use. If you use the same kind of thing with our bacteria, because as these nutrients, as these compounds are broken down into their elemental states, you are now able to more effectively utilize everything that's there.
I think another really interesting point was the level of flagellates that you're achieving. Now, you're not inoculating these flagellates. They're coming in as passengers on the food waste. And they're doing a tremendous amount of nutrient cycling, as well as keeping everything in balance. So again, this process has just been, so fun to explore, because it's not only an amazing use for food waste, it has just incredible potential for what I want to say turning fields. So in a traditional ag field, you have no biology. You have bacteria, but you don't have any advanced biology. Where if you introduce this product out of the gate in a low oxygen environment like a traditional ag compacted soil, you're going to have a tremendous response. So you've pretty much jump started ecology with the creation of this product. And just for the audience to understand, traditional or food waste at this point in time is just being tossed into landfills and turning into gas. It's gas.
Yeah, we could certainly speak a little bit to that. That right now, that's actually one of our biggest problems, especially here in Southern California, like in LA County. I don't remember how many thousand tons of food waste it goes to landfill, and they have legislation in to require diversion, and that's always it's being pushed back. But we can take all that food waste and divert it from the landfill, which is hugely important, because as you were just saying, that material going into the landfill, well, that is just producing toxic gases, and it's dangerous. It can get up over 1,000 degrees down in the landfill, I believe. It's insane, and it doesn't need to be going there. We can divert it through our machine, and we can process all of that. And there's a couple of things here that I'll mention on that. One, we can turn it into this super bioactivated fertilizer product, which is great. But there are also some regulations. There's certain organics that you can't send out to be fertilizer. So, okay, fine. You can, if you aren't going to do that with those portions of the waste, you can just process that stuff and send it down the drain. And it's perfectly safe for the sewage systems. It will actually improve the sewage systems all the way to the final processing there, because that bacteria is just going to continue doing what it does as it's running through that system. So it's a win-win situation. There's just no downside.
And again, I think that, moving forward as a population that has an understanding of some of the problems that we have at this point in time, that it's critical that people hear about this and understand that there are other alternatives.